This is lesson 11.3a. We've already done the second half, which deals with circles. Today we're going to talk about the area of regular polygons. Okay, I do want to emphasize that this only works for regular polygons. That is, polygons that have the same, all sides are the same length, all interior angles are the same measure. To figure out this, it's quite simple, and I'm not going to belabor this point, but if you draw a point in the center of any regular polygon, and from that point you draw segments to every vertex, what you'll see is that you have one, two, in the case of a pentagon, you have 5 triangles. And so if I wanted to find the area of the entire polygon, let's say I have side length is this S right here. All I have to do is multiply the areas of these 5 triangles together, and that should give us the entire thing. I'm going to call this height, the height of this triangle, A, for reasons you'll see later. And let's find the area of one triangle. Not the whole pentagon, but just one triangle. Area of a triangle is 1/2 base times height. So 1/2, the base is S, the length of the side, times the height, which is A. Okay, if I wanted to find for the entire polygon, that is for the pentagon, draw a little pentagon here, it's going to be 5 of this. 5 times 1/2 times the length of the side times A. Okay, I want to point out here that 5 times this side. Well, if the side length S says, if I add 5 of them up, that's just the perimeter. So I can replace 5S with perimeter. Still got the 1/2, still got the A. That's our formula right there. It's going to be on the next page. So write this down. For a regular polygon, the area is 1/2 times the perimeter of the polygon times A, which is the apothem height. Apothem, it'll show up on the next page. Okay, area equals 1/2 PA. Pause if you need to. All right, the new word is apothem. It is simply a segment that connects the center of a regular polygon and one of the sides, and it has to be perpendicular to the side. These are the steps to using A equals 1/2 PA. The first thing we always need a picture. The first thing we need to do is draw the polygon, if it's not already drawn. And then an apothem. From the apothem, we're going to make a right triangle. We need to find the measure of the center angle, and then we need to find the lengths of the legs. We'll either use special triangles, in the case of a regular triangle or a regular hexagon. Otherwise, we'll have to use trigonometry. Finally, we plug stuff into our formula. So, this is an extremely simple example. I can obviously tell if this is a square, if halfway across is 3, then the side lengths are 6, and the area should be 36. Well, let's just test out our new formula. The first step is to draw the polygon. That is done. The second step is to draw an apothem. Well, I remind you that apothem goes from the center to one of the sides, and it has to be perpendicular. So that step is also done. The third step is to make a right triangle. I'll go from the center to a vertex, and so that line that I just draw, the apothem, and half of the side length is going to tell me, that's going to make the sides of my triangle. Now I have to find the lengths of the legs. This is where I have to find the center angle. Alright, so in this case, what I want you to realize is that if I were to draw triangles, or lines, segments from the center to every corner, I'd have 1, 2, 3, 4 triangles. Now, this is 360 degrees in a full circle. That means each one of these 4 angles is 90 degrees. In the top case up here, my apothem splits that in half, and so my center angle is 45 degrees. And of course, if this is 45 and this is 90, this has to be 45. Once you know this center angle, then you can find the other leg lengths. Clearly, this is an isosceles right triangle. If this is 3, this is 3. We do not need to know the length of the hypotenuse. Okay, now that I know the length of the legs, I can find the perimeter. I'm going to step back real quick and just look at my rules. Find the length of the legs, and then area equals 1/2 PA. Okay, so we're ready to go. A equals 1/2 times the perimeter times the apothem. Well, 1/2 is 1/2. The perimeter of this square, let's see. If this guy is 3, this guy is 3. So the whole length this side, the whole length is 6, 6, 6, right? This is a square. So if I add up, the perimeter is going to be 24. The apothem height That's 3, just as it has been from the beginning. Half of 24 is 12. 12 times 3 is 36. So we get the same answer. Now, in the case of a square, you never want to use this cumbersome formula, but I just wanted to take it for a simple test drive. Okay, let's try a pentagon. It says with a perimeter of 90. And we have to find the area. Okay, the first step is to draw the polygon. Done. The second step is to draw the apothem. So I'm going to put a point in the center, and I'm going to draw straight down at a 90-degree angle from the side. I'm going to call this A for apothem height. The second step is to find, or to draw a right triangle. The next step is to draw a right triangle. Now we have to find the measure of this angle right here. Well, if I were to carve this up into different triangles, I'd have 1, 2, 3, 4, 5 triangles because there are 5 sides. 360 degrees in the center divided by 5 tells you that each one of these angles is 72 degrees. Because the apothem splits ours in half, this angle is 36 degrees. Okay, the next, after finding that central angle, we need to find the leg lengths. Well, given that the perimeter is 90, I know I can find the length of each one of these sides. I just divide 90 by 5, and I find that each side is 18. If I look at this triangle right here, this little half triangle, half of 18 is 9. Now, at this point, all I need to solve area is the apothem. So I'm going to redraw this triangle. This angle is 36 degrees. It's a right triangle. This is 9, and this is A for apothem. I'm using, it's time to use trig, the opposite side and the adjacent side. I hope you know that means I need to use tangent. The tangent of 36 degrees is equal to the opposite side over the adjacent side, multiply by A, divide by tangent 36. A is 9 over the tangent of 36, which is approximately, actually I don't care right now what it approximately is equal to. I'll just leave it like that until I plug it into the formula. Area equals 1/2 the perimeter. They gave me the perimeter is 90 times the apothem, which I figured out is 9 divided by the tangent of 36. Okay, we'll simply plug this into the calculator. 1/2 times 90 times 9 divided by the tangent of 36. Okay, 557.4. Approximately 557.4. Okay, and now a hexagon. So we're just doing different shapes, and I'm giving you different information to begin with. All right, well, let's go ahead and write down the formula. All right, the first step is to draw the hexagon. Done. Draw the apothem. Done. Draw a right triangle. Done. Okay, and now we've got to find the center angle. Well, let's see. This is a hexagon. I could carve it up into 1, 2, 3, 4, 5, 6 triangles. 360 degrees divided by 6 means this is a 60-degree angle. And since the apothem splits it in half, I have a 30-degree angle here. Okay, I'm going to take this triangle right here and redraw it. Hopefully you're already figuring out where this is headed. I have a 30, 60, 90 triangle. The short leg should be the long leg, or rather the long leg is the short leg times the square root of 3. In this case, the long leg is 24. To find the short leg, I divide by the square root of 23. The short leg is 24 divided by the square root of 3. Okay, so I'm going to put that here. 24 divided by the square root of 3. Now, this is only half of the side. To get the whole side length, I would have to double that. 24 times 2 is 48. So I have 48 divided by the square root of 3. That's the length of each side. The perimeter is, of course, going to be 6 of those. So let's go ahead and plug all this in. The area is 1/2. The perimeter. The perimeter, we said, is 6 times 48 over the square root of 3 times the apothem, which they told us is 24. So you'll notice in this case, because I had a special triangle, I didn't have to use trig. Let's pull our calculator back up and plug all this in. 0.5 times the perimeter, which is 6 times 48, divided by the square root of 3. Need to close that off. Oops. Or just get from underneath it, times 24. 1995. We'll say about 1995.3 square inches. Okay. Find the area of the shaded regions. All right, now we're getting our circles involved. We want to find the area of the shaded region. Okay, well, I hope you can see that the area of the shaded region is going to be the area, let's see, the area that's shaded is going to be the area of the whole thing, that is the area of the circle, minus the area of the not shaded part, that is the area of the triangle. So I've actually got two problems to figure out here. One is the area of the circle, and it should be quite easy. The area of a circle is just pi times r squared. The radius of the circle is clearly 7. So the area of my circle is 49 pi. Now we have to figure out the area of this triangle. This is a little bit more complicated. This is an equilateral triangle, which is to say it's a regular triangle. So we can use our new formula, area equals 1/2 PA, or we can use the old. Let's use the new one. Okay, I've got my triangle drawn. I need to draw an apothem. I'm going to go from the center straight down 90 degrees. There's the apothem. Okay, got the apothem. Now I need to find the central angle. Well, with a triangle, I can carve it up into 1, 2, 3 triangles. 360 degrees divided by 3 means this is a 120 degree angle. This is split in half, so this is a 60 degree angle. And we are in luck, because once I redraw this triangle, hopefully you might have already seen that this is a 30, 60, 90 triangle. The hypotenuse is 7. Well, the short leg is half of the hypotenuse, so the short leg is 3.5. And the long leg is the short leg times the square root of 3. So if this one short leg is 3.5 square root of 3, then hopefully you can see that the other short legs, or the entire length of the side is going to be twice that. Twice 3.5 is 7. So this is 7 square root of 3. Okay, and so let's find the area of the triangle. The area of the triangle is going to be 1/2 times the perimeter. Well, the perimeter, it has 3 of these sides, and they're each 7 square root of 3. 1/2 perimeter times apothem. Apothem is 3.5. Okay, and let's go ahead and abbreviate that, or approximate it rather. Pull this over so I can see while I punch this in. 1/2 times 3 times 7 square root 3 times 3.5. Approximately 6365. Okay, so to find the area of just the shaded region, I'm going to take the area of the circle. We said that's 49 pi. And I'm going to subtract the approximate area of the non-shaded region. And let's punch that in the calculator. I'm just going to say 49 times pi. And I'm going to subtract the answer. About 90.29. That should be the area of this shaded region. This flap and this flap and this flap.